Um, Good morning. Uh, in today's class, I'm going to switch to the bivariant statistical measures. So please take your time to go through the univariant statistical measures. I mean the likes of variance, the like of standard deviation and coefficients of variance. Please take your time to go through it and know the real life applications and how to interpret the values into real life application. So in today's class, I'm going to be taking you on bivariant statistical measures, and I've prepared a slide that will take you through the course. And by the time I've been able to give you the formula, then we'll apply the formula by doing it manually in Excel. And after this, we would use software like SPSS to do it practically, because I know a lot of students are always scared of anything calculations. So we are just doing that for you to have the understanding. So, but you might not bother if you don't really like calculation. Just watch the parts in which I use the software to get my bivariance statistical measures, the likes of covariance and also of correlation. So when you are talking about bivariance statistical measures, it means that I'm dealing with more than one variable. So in this context, we are going to be using two variables to explain this to us. So I'm going to be using real estate. Uh, that's when you are talking about size and you are comparing it with price. So let's go to the major cause. So I'm going to start with covariance. Now, what is covariance? Let me type it so that as I'm typing, you can follow me as well. Now, covariance helps to measure the relationship between between two variables. So, are the variables really related or are they not related? What I mean by related, that's why I'll be using real estate as a case study. So, for example, now the two major variables is the size and the price. It's always norms anytime the size of a building increase. So the prices increase. So that's why that can give you an understanding that the size of a building is related to the price. So there's an upward trend. So I'm going to be using a sample data in Excel to explain this. Let me see if I've even downloaded it. Let me check my download. Okay, so I have a sample data for that. Let me open it so that you would be able to see it yourself. Okay, now looking on the screen, you could see that I have two major uh, columns, even though the first one is just the outside D, it does not matter. But the major thing is the size. And let me bold the first row. Okay, so the first one is the what? The size. And the second is the what? Is the price. So you'll notice that when the size is 800 square feet, what happens to the price? The price is 150,000. When the size increased to 1,000, the what? The price automatic. That's the norms in real estate. So the price of a building increases as the size of the building increasing. So before we actually do this, let's quickly go through the formula so that we have the understanding of what is really happening. Now, looking at the formula, you could see that the formula states that COV X and Y. X is the size, as shown you in Excel, while Y is simply the price. So now to get our what is it called? To get our covariance, you will do the difference between the what? The the size and the mean of the size, then the difference between the what? The price, each of the price, and the mean of the price, then you divided it by what? N. Even though I don't need to go through this, you understand that when you are dealing with samples, you use n minus 1. So this is a formula for population, and you know that in this case is actually a sample. It's not possible for just 7 buildings to be in a population, so it's a sample. So we are going to be using n minus 1. I think that is clear. So let's quickly go to Excel and see how we are going to do justice to this. So the first thing I'm going to do, let me copy the formula so that you can follow me as I'm actually doing it. Copy the formula to my Excel. Okay, let me just put it somewhere here. Control V. Okay. Okay. Now, according to this, that means the first thing we need to do here is that we need to get the mean of the size variable and the mean of the price variable. This is not new for anyone in statistics or data analysis. So how do you get the mean? And don't be bothered. Don't worry. We are going to do it with ease using SPP. But I just want us to know how we arrive at the answer in the software. So now, to get the mean, which is simply the summation, sum of all the values, exactly, divided by the what? The number, which is what, 7? Exactly. So this is 1500. Then let's look at the mean of this one also. That is the price equals what? Sum. We'll get the total. Then I'll divide it by what? 7. So the mean of the price is also what? 250. Now, after we've gotten the mean, the next thing we are going to do is that let's use the formula as stated there. So now the next thing I'm going to do now is that I will start using what? The okay, sorry. I'll start using the formula, which is what? Each of this value, which is equal. Are you following? Let me put parenthesis. This minus the mean of the what? The mean of the size. If I really want to make it very easy, let me do it separately so that I will multiply it later, so that people that are not very good in Excel will understand that. So what I'm doing now is that I'm getting the mean of each of it. So the mean of this one minus this is it. So the next thing I'm going to do is what? Okay, let's do it together, right? Okay, then multiply. Okay, let's do it separately. Let's do it separately. Did you get? So what I'm actually simply doing is that, look at it. But I will need to lock the 1 5 so that you use the same 1 5 or 2. So that means I'll put $sign. I'm sure we understand this. So the essence, let me show you. The essence of that is that each time I'm using this with this, each time, oh sorry, you understand? 1 2 minus till the bottom. So this one is the difference for what? For the size. Size difference. Let me do it like that. Then after that, price what? Difference. that is from the mean. So that means this one will also be what? Equals each of it minus what? The mean. Exactly. Then I will lock the mean for the price by putting dollar sign. Okay, then I'm going to drag it down. Are we following? So let me be sure if it's right. Okay, so it's right. Now, after we've gotten that, then the product of the difference. So let's look at the product. I'm trying to explain that is the product of the difference. That's what I'm doing. Product of the difference. So for the product of the difference, that's going to be what? Equals this multiplied by what? Multiplied by this. Are we making any sense? I will enter. Then I will drag down. Am I making sense? Now, sorry. Why is this place? Oh. I'm wondering why this place is zero. I think I know the reason now. So now, after that, after we know the product, so we now do the what? The summation, which is equals what? Sum, then all true. Am I making any sense? Okay. Now, after we've gotten this, the next thing is we now divide it. So let's now talk about our what? COV, covariance. Will simply be what? Equals this. What's the total? That's n minus 1 is 6 divided by, and we will know if we are right or not by the time we use divided by 6, because it's going to be n minus 1 divided by 6. Okay. So do you know the meaning of this? This is 39,000. That's the covariance. Now, the covariance is what? 39,000. Number one thing you could get from this is that let's quickly look at our interpretation of covariance. I think this will understand us, this will help us to understand better what I mean by the interpretation. Let's look at the interpretation of covariance. Say covariance greater than 0, like this. It means that the positive relationship as one variable increases, the other variable also tend to what? Increase, which is right. That is, as the size variable increases, that's what we said initially, the what? The price will decrease. Sorry, will increase. But if covariance is less than 0, that's negative relationship. As one of the variable increases, the other variable tends to what? Decrease. I'll give you an example. By the time we okay, let me just give you the example ones that follow. For example, now, maybe exercise and weight. For example, now if I have a data, or maybe I should give you as an homework, if you should do a data on exercise and what? Maybe the hour of exercise and weight. What will really happen is that as the hour of exercises is increasing, the what? The weight will decrease. That's a very good example in that. So the other variable is the weight will what? Will tend to decrease. That is negative relationship. But when covariance goes to 0, it means no linear, there's no relationship at all. They are not changes is in one variable do not predict changes in the other variable. I think you are you've really gotten that clearly. Aha. So let's go to the second one, which is what? Correlation of variance. Now you will discover something under here before I go to correlation of variance. Fine, this is 39,000. The data or the value is too high. You can have 50, you can have 100, 1,000, 100,000, like that. So it's better we put it in a way that it will be more easier to interpret. That is why the second topic is actually coming forth that I'm going to be showing you now, which is what uh okay, which is what we call correlation coefficients. Correlation, let me correlation coefficient. Now, when you're talking about correlation coefficient, it's still the same thing. It's still for relationship between the two, but the only difference is that you can easily interpret it because the value will be very small. You understand? It's either is less than one or is okay. Let me type so that you get what I'm actually saying better in this case. Now, for correlation, is still the same definition as what? As covariance, but the only difference is that you can what? And get better interpretation with what? Interpretation, sorry, with correlation in the sense that when you have correlation value of 1, which means that perfect positive relationship. Are you getting me? Perfect positive correlation. You can call it like that. That is, it is perfectly related. Do you understand? So when is that means when your value is very close to 1, to a very good extent, you will know that there's a very good relationship between them. Exactly. And the formula is also very simple. Formula is also very simple. So by the time you have your covariance, you are almost through. So you just do your covariance divided by what? Divided by the product of the standard deviation of the first variable by the standard deviation of the second variable. But pardon us all this stress. By the time I will use what I call SPSS, you will not need all this, but we just need to put you through this so that to give you a detailed understanding of the. So let's go to our Excel again, uh, and really convert this to. Okay, don't let us bother about that. Let me see if I can quickly do that. So definitely, since I have my mean already, that's another work. Don't let us, so that I will not just take my time. Just read our video on standard deviation, because if I want to get the standard deviation now, you must know that I need to get my variance. After I've gotten my variance, I will now do the square root of my variance. So watch the pro video. I think that will explain. So let's go to the software and round up the video for this class. Then I will do the real life application of the course. So now just see smooth work by just having uh, our software. So let's quickly do something and see the difference. Now, the first thing I will need to do is what? So you that you don't like calculation, just follow this. If you're able to get this, you might not need to bother. So by the time you have understanding on how to do it in SPSS, the next thing you just need to do is what? Just know the interpretation. So now the first thing is a file open. What I'm actually trying to do is I'm trying to import the data so that I will not need to be typing. Open data. Okay. Excel. Sample data for, where did I keep it? Let me see if it's in download. Okay, standard deviation equation. No. Sample data for covariance. Yes, this is it. Okay. We are waiting. Okay. So this A1 to C8. Let me be sure that is correct. A1 to C8. Okay, it's correct. A1 to what? To C8. Wow, it's correct. So after that, I'm just going to click on OK. Then after I've clicked on OK, can you see the data is imported already? So when you have the data, so these are for 8 houses. So as you can see, as the size increase, the price increase. So I want to know the relationship between the two, how related they are. So please take my small phone. Mm, My small phone. Mm. So I want to know how perfectly related they are. So you can see that in this case, I'm just going to go to my analyze. Then when you get to analyze, go to correlate, then go to bivariance. Both correlation and also the covariance is still under. So for the covariance, so I will have to drag the size and the what? And the price. Is that clear? So then after that, I will go to option. Then I will do my coming cross product deviation and covariance. Let's see this. Exactly. This one means that if you still want to get your mean, your standard deviation, that's the excess of this. If you like also, you can select it. Are you following? And at the end of the day, you click on OK. So let's see the interpretation. Now from this, we can get that, okay, they give us the mean, the standard deviation. Okay, we're okay with that. But that's not my concern. Come in. Okay, this correlation. Okay, for the correlation. Okay, correlation is significance and blah 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 blah. Using correlation, this one is for the price one, sum of square and cross product. Okay, let's look for the covariance. Can you see? So that means we are right. The other time it was 39,000. Is it? Let me see what I got when I was using 39. Is it on 39,000? No, 39 million. Aha, 39 million. So that's our covariance, which means that we are actually what? We are correct. Exactly. So if since they've given me my let me look for the since they've given me my standard deviation, I can even do the coefficients. I can even do the correlation easily. So let's look at the standard deviation. The standard deviation for size is this, and that of, so let's quickly, let me see if I can copy. Okay, I can copy. Let me just use it. So the next thing I'm going to do is that 525.991. 525.9. So I will, okay. So I want to calculate because a lot of time it might not give you a very specific stuff for your correlation. But let's calculate and see if you are right. So 525.99. So let's look for the, for the covariance, for the correlation, I told you that is your COV divided by the product of the standard deviation. So that means let's look at for the product of the standard deviation of the two of them. Product of what? SD for the two of them, which is simply what? Equals, let me pick it from there. This is what? Please try and look for size 525.991. Oh yeah, 525 525.991 multiply by, so I want to also get the standard deviation of the price, multiply what? By 74161 74161 74161. Pray I'm correct. 74 74161. Okay. Dot 985 dot 985 dot 985 dot 985. Oh wow. Did you see? So this is the product because I multiplied the two. So after you've gotten the product, so definitely to get my correlation coefficient is going to be simply what? My standard equals my what? My COV divided by my product. Oh, wow. Wow, I love this. So it means that my correction coefficient was 0.999. Do you know the meaning of this? It means that, I told you that when it's 1 is perfect positive correlation, that is highly correlated. That is the variability of one. As it increases, the other one also what? Increases. Are you getting me? So this one, imagine something is 0.9. That means it's closely related. That's the meaning of it. It's closely related. I think that is clear. So 0.99, let me see if what our distance calculator is right. Did you see anything like 0.99? Okay, okay. Business correlation. Maybe just round it up to 1. Do you understand? So that's why you are seeing 1 here. So it rounded it up to 1. So I think we now understand the what? How the importance of the bivariant statistical measure. I mean the covariance and the correlation coefficient. But some people will just call it directly, they will call it correlation. So let me now quickly take you through to the real life application of it. That is, how can you use it in real life? For example, now you can use it in healthcare. For example, you can try to correlate the hour of exercise per week with blood pressure. You are trying to know how correlated they are. Is it that when the hour of your exercise, when they increase, will your blood pressure decreases or will it increase? So by the time you get your figure, now to see if increased exercise is associated with what? Lower blood pressure. The value that you get. For example, now if you get a negative value, it means that, oh, when your exercise increases, it means your what? Your there'll be lower blood pressure. So you can also use it in finance, correlation between the performance of two stocks. You understand? So you can check, oh, is there correlation between two stock purpose? Like portfolio manager uses it to diversify investment. So you can choose assets with low or negative correlation, reduces risk. You can use it in education, you can use it in real estate. So the major one we actually use for this is what? Real estate. And I think it has really helped you to understand correlation. As you can see, is actually what? 0.99. So it means that they are highly what? Correlated, in the sense that when the sizes of the houses increases, the what? The what? The prices will increase. Are you getting me? But I told you one of negative. Negative means that if it's less than what? 0. That's when I use exercise with weights, because it means that they are moving in opposite direction. I've explained all that in the slide that I show you. So let me quickly go through it again so that I will round up. Can you see? Correlation greater than 0, positive linear relation. As one variable increases, the other variable also increases. So when it's less than 0, negative linear relationship. As one variable what increases, that's when I talk about exercise. Oh, when your exercise increases, your weight will what? Decreases. Correlation equals 0. There is no relationship at all. So the value that you will get at the end of the day will tell you what is really happening. So take your time to go through the video. See you in the next class.